Hi, and thank you for joining us today. My name is Ilya Epstein, and I'm a Principal Solutions Architect with AWS. I'm joined by Jeremiah O'Connor, who is also a Solutions Architect with our Global Financial Services team. In today's talk, we're going to discuss how our financial services customers are building their data lake architectures on AWS. In terms of the agenda, we're going to start with the why. What are the key drivers for building a data lake on AWS? And then we're going to talk about the how. What are the key considerations? What are the reference architectures in order to build a financial services ready data lake on the cloud? And then Jeremiah is going to do a demo of how AWS services can be used to help you accelerate building a data lake in the cloud, including things like fine-grained access control for your data lake. So let's get started. So what are some of the key drivers why financial institutions are building data lakes on the cloud? We're seeing a proliferation of data and explosion of amount of data that is being collected by financial services customers. 90% of the data worldwide has been generated over the last 2 years. And this is actually accelerating. Just a few years ago, that was every 5 years. We're seeing terabytes of data from new data sources, and it's no longer just structured data from your transactional systems. Data is coming from your semi-structured data sources like social media, as well as completely unstructured data from your emails or communications with clients, or even voice recordings from call centers. So what's driving this need to have so much data? We're seeing really 4 categories of use cases why customers are building data lakes and the need for data lakes to be able to sustain that. The first one is around compliance and regulatory reporting. We have new regulations such as Consolidated Audit Trail, which, for example, is causing 22 exchanges and 1,500 brokerage dealers to send over 100 billion events to FINRA every single day. In the business analytics space, customers are looking to take advantage of siloed data that previously they couldn't use, and they want to be able to improve not just business opportunities, but they also want to improve capabilities such as fraud detection. Customers are also looking to improve experiences for their customers. So for example, in asset management, we're seeing a proliferation of personalized advice that companies are trying to develop. And of course, risk management is another key area. Everything from market surveillance to portfolio optimization to backtesting trading and investment strategies, all of this is driving for a tremendous amount of data to be analyzed. And AWS is helping our customers to really help them transform by enabling them to modernize their different legacy systems to improve agility and scale. So first, we provide financial services institutions across banking, payments, capital markets, insurance, a secure and resilient global infrastructure. AWS now has 76 availability zones within 24 geographical regions around the world. And we have 3 regions actually coming online in Indonesia, Japan, and Spain. Second, we have a huge breadth and depth of analytics and machine learning services. So for example, on the left side, you could see here, you have your data sources. These data sources could be on-prem or they could be in the cloud. And that could include structured data from your transactional systems, your ERP, CRM systems, and business applications. We have semi-structured data, which coming from social media applications, points of sale systems, and then we have completely unstructured data from your call centers or from your emails and other communications with your customers. We take all of that data and we help you ingest that into the cloud. So we see 2 patterns, primarily batch loading as well as streaming. So batch loading, you could use our services such as Amazon MapReduce service or Amazon EMR, which allows you to ingest data directly from, for example, databases using techniques such as Scoop. We also have our fully managed AWS Glue ETL service. And you could also go ahead and get data in batch mode from databases, for example, using our database migration service. But we're also seeing a lot of streaming data that customers want to push in, and they're using services such as Amazon Kinesis, as well as Amazon Managed Streaming for Kafka, as well as the new AWS Glue Streaming ETL. All of that data lands in our Amazon S3 data lake. S3 becomes the cornerstone of your data lake. S3 is highly scalable. It has 11 nines of durability, infinite storage capacity, and it has amazing security capabilities around encryption and being able to provide both server-side and client-side protections of the data. Once the data is landed in the S3 data lake, you also need to make sure that you could provide governance of that data. So you could use services such as AWS Glue, which provides a data catalog, so you could know exactly what's stored where. And you could also then permission that data. And we're actually going to talk a lot about this, permissioning of this data in a fine-grained access control manner with services such as AWS Lake Formation. And Jeremiah is actually going to do a demo on that. Once the data lands in the S3 data lake and it's governed and it's permissioned, now you could perform analytics and machine learning. So on the right side, on the top, we have all of our different analytics services, everything from Amazon Redshift, which is a business warehouse service in the cloud, Amazon Athena, which is a fully managed query service in the cloud. You simply just run your query and get data results directly on the data that's on S3 or in other data sources. And then we have services such as Elasticsearch for search capabilities, and even BI tools such as Amazon QuickSight. And then we also have machine learning capabilities. And in the machine learning capabilities, we really are focused on different types of users when it comes to machine learning. So we have things like AWS Deep Learning AMIs. Those are for machine learning, deep experts in machine learning, such as machine learning engineers who are building their own frameworks, building their own algorithms. We also have the Amazon SageMaker platform that allows you to really manage the entire life cycle of machine learning, everything from building to testing to deployment, as well as monitoring and continuous improvements of the machine learning models. And we also have higher level services, AI services, that actually don't require any machine learning expertise. They are API enabled services, so things like transcription services with Amazon Transcribe or translation services with Amazon Translate, where you could, for example, take data from your call centers, transcribe them, and then do sentiment analysis, for example, with services such as Amazon Comprehend. So we build out the data lake, and then we're able to perform analytics and then machine learning. So that all sounds great, but what does it mean in terms of financial services institutions? We know that financial services organizations are not only enterprises, but they're highly regulated. So there's additional considerations and concerns that need to be addressed before you're able to perform analytics and machine learning. And let's look at what some of those are. The foundations really start with good data management and governance principles. And these really apply not just in the cloud, they also apply on premises. And we've broken them down into 7 categories. The first one, of course, is accountability. You need to make sure that all of the data that you're going to bring into a data lake, that you know who the data domains, you know who the data owners are, who are the data stewards that need to approve access to the data. And of course, you want to be able to capture that data in a catalog. And we're going to talk more about that, and the services that we have to support that. Data accuracy is important. When you're ingesting data from different data sources, you want to make sure that you have validation of that data. Making sure that you have the completeness of that data, and you also want to make sure that you have data models that you're going to be able to build on top of that data, whether it's physical data models, logical data models, and eventually conceptual data models as well. Data quality is really important, especially within financial services. If you're going to be taking action on this data, you want to make sure that the data is good in terms of quality. And this is not just, kind of technical aspects of that quality, but also from any integration logic that you may have. From a business perspective, you also want to make sure that you have data quality checks that are embedded in that process also. Data lineage is another key area. You need to be able to understand all of the data movements from the original source all the way through to consumption, how that data, what sources that data came from, how it has evolved, what kind of enhancements have been done to the data, and really be able to track all the stages in that process. Operational excellence becomes another big area that our customers need to consider. So you want to think about SLAs, for example. as a data platform, as well as management of the different services that you're going to use as part of your data lake, you want to make sure that all of your consumers within the line of businesses have clear understanding of what the expectations are in terms of operational resiliency. You also want to define, for example, data lifecycle. When you move data to the cloud, as an example, you may want to be able to transition it to different types of storage capabilities, and all of that is part of that operational excellence capability. And then, of course, security is super important, right? Especially within financial services, we need to think about data protection, user entitlements, fine-grained access controls, who, what, when, where, and you want to be able to not only have these controls in place, but you want to think about defense in depth. You want to think about layered controls in terms of preventative and detective controls, and then you have to have good auditability of those controls and auditability of access. That's all under the security umbrella. And then, of course, data privacy. You really need to think about data classification. Where does data fit in terms of, is this public, non-public, confidential? Is it highly confidential data? And once you classify your data, you also need to start thinking about what are the different controls you need to have in place with that data. Those controls could be both a combination of, security controls or technical controls that you implement, but it also could be processes around the management of that highly confidential data that is subject to various data privacy regulations. So these are the 7 key foundational principles that our customers focus on. What I want to do now is zoom in a little bit on the security aspect, because this is where a lot of our customers in financial services spend their time, making sure that when they're building their data lake in the cloud, that it's secure. When it comes to security considerations, we really see 5 buckets, right? And the 5 buckets are around authentication and authorization. So how do people access? How do data scientists, data engineers, business analysts, how do they authenticate to that data store? How do we integrate that with things like Active Directory? Authorization is around permissioning of that data. We'll talk more about this, and Jeremiah is actually going to do a deep dive demo on this aspect in terms of fine-grained access control. Auditing is really important as well, like we talked about, being able to understand who accessed the data, and really audit not just on the catalog, but also audit of the underlying storage of the data as well. Private network connectivity is another big area. Our customers, especially if they're putting, non-public data in the cloud, they're putting confidential or highly confidential PII data. They need to make sure that this data is never exposed to internet, for example. So we'll talk about what are some of the controls and capabilities you could develop in that area. And then, of course, data protection. Data protection is all around making sure that you have encryption policies defined. And really, our recommendation and what we're seeing as a pattern is financial services customers really encrypt all data in transit and at rest. And often, they also want to make sure that they control their encryption keys. So we're going to talk about those capabilities as well. So over the next few slides, I'm going to dive into each one of these areas and actually show you real reference architectures that we've seen with large financial services institutions in the cloud and some of the best practices in these areas. So let's talk about the first one, authentication. Authentication, one of the key drivers here is anytime you have access to the data, specifically human access to the data, human access management, you want to make sure that it's integrated with your corporate directory. You typically, especially if you're a regulated customer, you don't want to have separate identities in the cloud and separate identities on premises. You want to have that seamless integrations with things like Active Directory, using LDAP or other capabilities that you may have, and you want to make sure that you're able to authenticate users based on that. This really simplifies things like joiners, movers, and leavers. So when an employee leaves the company, you don't have to worry about their permissioning. It's fully integrated with your Active Directory. We see sometimes customers have additional authentication requirements. It could be things like Kerberos authentication. It's a good approach to think about the different resources in terms of transient and non-transient, and whether those resources require human access or they don't require human access. So for example, let's look at some patterns. Let's assume you have a ingest pipeline. So you have your data sources on the left side. They could be file systems, they could be databases. Um, you could have vendors that are sending you files. And let's assume here I want to ingest my data, and I'm going to use something like Amazon EMR, which is our Elastic Map Reduce service, but it's used very often in ingest pipelines. So I could spin up an EMR cluster here on the right, you can see in the middle, and that EMR cluster, I'm going to use an enterprise scheduler to go ahead and spin up that cluster. Maybe I'm going to use a build node because I'm using a CI/CD pipeline to actually go ahead and spin up that cluster. And then maybe for file systems, I'm going to use maybe a simple FTP server, right, to spin it up. The idea here is none of these components really require human access. All of these components could be fully automated, and all of these components really should be ephemeral and transient in nature. So we encourage you for these types of pipelines, eliminate human access, don't allow any type of direct SSH access, do everything in a programmatical CI/CD pipeline, decouple any type of job submission or logging information away from the cluster. So if you need to troubleshoot something, you could do this completely externally. And this will really help simplify your authentication posture for these types of ephemeral resources. Very similarly, we have a fully managed service, ETL service with Amazon Glue. So in that case, it's very similar. Glue is a fully managed service where it will go ahead, you could configure an ETL job. In this case, for example, I'm using a JDBC job to ingest data from a relational database. Here, I could just use simple IAM authentication to actually set up my Glue job. But again, in this case, you don't need for the users that are creating these jobs to have any access to any resources that are actually being created by Glue. It's fully managed. And you also don't need to provide the users any access directly to that raw layer that is being landed in the cloud. This could be fully automated and fully orchestrated. Now, when it comes to authentication, you do have to think about a little bit more in depth around permanent resources. What if I have a more permanent or longer lasting resource such as Amazon EMR Analytics cluster, where I'm spinning up that cluster maybe for the duration of the day or for the week, and I actually have some interfaces there. Maybe I have a Jupyter Hub or Zeppelin or EMR notebooks, and there I have human access, of course. And in that case, this is where directory integration becomes really important. A lot of the services that are running on Amazon EMR support integrations with LDAP. So whether you're using Hive Server 2 or Presto or Zeppelin or Jupyter Hub, you could configure AD integration. So when the users are authenticated into those UIs, they're not using separate identities in the cloud, they're logging with corporate credentials. And Jeremiah is actually going to show that in the demo later on, how that works, for example, with something like Zeppelin. So great, we have our authentication. We're now authenticated the user. The next thing that you have to start thinking about is authorization. And authorization, what you're ultimately trying to do is you're trying to take your AD users or AD groups that you have configured, and you want to be able to permission what they are able to do ultimately, both on the storage layer as well as on the catalog layer, right? So that's what we mean by storage authorization and metastore authorization. And it ultimately boils down to the user. Now, you may use IAM roles, the mapping that you're going to create between AD groups or IAM roles as a mechanism to be able to do that fine-grained access permissioning. Although Jeremiah is going to talk about a new model we have with Lake Formation that actually allows you to do direct mapping of AD groups and AD users to the underlying data that you have in your catalog. And customers typically want to do a fine-grained access permission here. They want to make sure that not all users have access to all data, and this is where having your logical conceptual data models becomes super important, because you could then permission different catalogs, different tables, different columns for the different AD users and groups. So how does that look like? This is actually part of kind of the demo that Jeremiah is going to talk about, but I'm going to show you an example here how you could use one of our services, AWS Lake Formation, to help you simplify that permission model. And in this case, we're going to use an example with Amazon EMR integration, where you have user who exists in a corporate directory, what you do is you configure that trust relationship between your directory and AWS IAM service. And then what happens is when the user is going to connect to Zeppelin or Jupyter Hub, they're going to use their corporate AD credentials to log into those UIs. And then what's going to happen is EMR is going to use an IAM role. That IAM role actually doesn't have any permissions to the underlying data. It has no permissions to the catalog. It has no permissions to the data store. It's just going to make a call to Lake Formation and say, I have a trusted identity here that I want to be able to access a specific data store. And what Lake Formation is going to do is going to say, okay, this user, based on their permissions in the catalog, is allowed to access this column or table in Glue, and it's going to give a set of temporary credentials which can then be used to then access the catalog to be able to see the metadata. And then Lake Formation is going to return another IAM role that will then allow the user to access the underlying data, and that data is stored, of course, in S3 and potentially encrypted with Amazon Key Management Service. The great aspect of this type of integration is that all of the IAM roles that are actually accessing S3 or the catalog itself are ephemeral, right? The user themselves doesn't necessarily have to have the permissions to the underlying data store. And Jeremiah is going to show you how you could then be really fine-grained in terms of access to the different aspects within the catalog. So this is a good approach that we're seeing being adopted by financial services customers to be able to take my corporate AD credentials, authenticate, and then authorize them all the way down to specific items in my catalog. Auditing is another key consideration, like we talked about, being able to audit both access to the data as well as access to the metastore. This is another area that Jeremiah is going to touch upon. Lake Formation plays a key role here as well, where you can actually see who accessed what. Sometimes customers may have additional requirements where they may want to capture full query logging, which is possible as well. The different tools that you're going to use, let's say whether it's EMR or it's Athena, all of those tools provide mechanisms for actually also logging the full query that the users are executing. And then, of course, being able to tie that back to the individual users in your AD. And I'm going to show you just some of the tools that could be used to help you with that regard. One of them, for example, is AWS Cloud Trail. So Cloud Trail allows you to, Cloud Trail in general captures the API calls that users perform within AWS. So if you're creating a bucket or you're deleting a bucket in S3, that is captured in Cloud Trail. But Cloud Trail has another interesting capability, which is Cloud Trail data events. Those are data plane events. So things like put object or get object could also be captured by Cloud Trail if you enable it. So in this case, we have Cloud Trail data events enabled. And what we're able to do is we're actually able to tie the specific IAM roles, but even specific AD users. Like you could see here at the bottom, we have an AD user called DTS1, and that user is part of an AD group called EMR admin. We're actually able to capture and see what specific bucket and object in S3 they were able to access. And that becomes a really important access log that you could use for an audit trail, as well as, by the way, as part of your data lineage architecture to really see who has accessed what and how that data has also been transformed throughout its life cycle. And then Jeremiah is actually going to show you this live in the Lake Formation console. Lake Formation provides additional auditing capabilities right within the console, so it makes it really easy and friendly for data scientists to interrogate and investigate in terms of who accessed what data. Another key consideration is around encryption. So what we typically see, and we recommend that all financial services institutions encrypt all of their data in transit and at rest. At rest, we typically see customers leverage our key management service, AWS KMS, and KMS has the capabilities to create what's called customer managed keys or customer managed CMKs, which means that you could actually be in full control of the life cycle of the key. So you could create the key, you could manage who has access and permissions to it. All of that could be managed in KMS. And we also recommend, of course, encryption of all the components in transit and at rest. And this is an example reference architecture that we see with our financial services customers, where here I'm using Glue ETL to transform data from the different layers of my data lake. So I have my raw layer, and then I have my process layer, and then I have my consumption layer, and I have ETL jobs that are being performed between the layers. I also have something called glue crawlers, which are automatically identifying new data and storing them in my catalog. And the nice thing is all of these components are fully integrated with Amazon Key Management Service. So my buckets could be encrypted with a customer managed key. My Glue ETL jobs could be encrypted, but also the logs that they generate could be encrypted. And all of the traffic in transit is encrypted as well with TLS. Private network connectivity is another key consideration. So when customers build out a data lake, especially if it contains obviously confidential or even highly confidential data, they want to make sure that it's all deployed in a private network, no internet connectivity. And here, this is where our customers take advantage of technologies such as VPC endpoints, which allows your resources in your VPC or your virtual private cloud to talk to other resources like your S3 buckets, for example, without leaving the Amazon network and without having to use public IP addresses, without having to go to the internet. And this is the architecture that we see here. So on the left side, we have our data sources, we have our databases, we have our files. In order to connect to the AWS cloud, we're using secure connectivity. So we're using AWS Direct Connect, which are leased lines that you could provision to the AWS region, or you could use VPN tunnels or possibly both to establish that secure connectivity to the cloud. And then all of the components within my VPC, the actual applications, for example, that are deployed on EMR, all of those do not need any public access. They could just be using private IP addresses. So all of this is using private IP space. And even when I'm talking to resources in the region, so such as S3 buckets, or if I'm talking to AWS Glue at the bottom here, those services have something that's called VPC endpoints, which allows you to talk to these services without having to go to the internet. So all that traffic stays private and you're using only private IP addresses. Okay, so with this, I'm going to actually pivot and hand it over to Jeremiah, who's going to talk about AWS Lake Formation and Glue and how those services could help you build out a data lake in a financial services readiness manner, and how you could properly permission your data lake with fine-grained access control.
Thanks, Ilya. So before we jump into the demonstration today, I want to talk a little bit about Lake Formation and some of the capabilities that it has. So first, what is Lake Formation? So Lake Formation is our fully managed service that enables your data engineers, your data stewards, your data analysts to build, clean, and secure data lakes in days. So prior to Lake Formation, the process of standing up a data lake on AWS involved setting up ingestion pipelines to dump data into S3. Then once your data was in S3, you needed to manage and set up all of these complicated bucket policies, object policies, and try and figure out which piece of data needed to grant access to which user. And so that process typically took anywhere from weeks to months. And so the goal of Lake Formation is to cut this process down to really enable your data stewards to be able to innovate very rapidly and develop this data lake in AWS within days. All right, so what does the solution stack of Lake Formation look like? So at the base layer, we have Amazon S3. And so S3 is going to be the data lake storage mechanism that we're using. The reason we do that is because the S3 is very cost effective. It's a durable storage solution, and it comes with global replication capabilities. So if we need the ability to replicate the data that's in our data lake to another region, we have that capability with S3. On top of that, we have Lake Formation. So the first half of Lake Formation is the ability to ingest and clean data from multiple different sources to enable your data engineers to build your data lake out faster. And so we do that with a couple of different services. So we have AWS Glue integration, which allows you to write your ETL code to push data into your data lake. Then we also have Lake Formation blueprints, which are pre-built templates that allow you to connect to popular data sources that you can automatically ingest and set up workflows to push your data into your data lake. The second piece is a centralized management of the fine-grained permissions model that empowers your security officers to define permissions for who is allowed to access what on your data lake. And what ultimately that allows you to do is it allows these integrated services the ability to have discovery of data, to be able to share data, and to integrate these tools to enable your business users or your consumers to be able to read only the data that they're allowed to see. And so we'll talk a little bit about how that actually works. So when we're setting up lake formation, essentially we break it down into 3 different stages. The first stage is registering the S3 location. So where do you want your data lake to actually be? You can define one S3 location or multiple locations. And 2, you're going to create what we call databases and tables. So these are logical representations of the data that's sitting on S3. So as opposed to your users actually interfacing directly with objects that are in S3, they're interacting with a database or a table that is referencing that S3 data underneath the hood. And what that allows us to do is move into stage 3, which is granting permissions. So with lake formation, we give you the ability to grant permissions to IAM users, roles, Active Directory users, and groups directly to those tables, to those databases, and even to the column level. And so we'll dive a little bit into what that process actually looks like. So we have this centralized permission model within lake formation. So your data administrator will set up user permissions on data lake resources. Now, data lake resources are going to be those tables, databases, and then columns I was referring to. And what this allows you to do is this allows your data admins to set up who needs to see what, who needs access to what within your data lake. Then when your users are trying to access this data from one of these integrated services that we have over here, lake formation has to authorize that user based on the policies that your security administrator defined. And so what this allows you to do is lake formation is then unifying that data access permission model in one location. So what does that look like? What does the permission model actually look like? So with AWS Lake Formation, you control data access with grant and revoke permissions. So you're no longer having to configure complicated JSON security policies. We've reduced that down to very simple grant and revoke permissions. And what this allows you to do is specify permissions on databases, on tables, or on columns, or a combination of the 3, rather than having to deal with bucket policies and object level policies. This also gives you an easy view into those permissions. So as your data stewards or your data administrators are able to see all of the permissions that are granted within your data lake in one location. And then finally, we'll show this later in the demonstration, but also we've aggregated a lot of that auditing capability into one location as well to be able to determine who is accessing what on your data lake. So here's an example table that we have here that's got a number of different columns, and we have 2 users that we want to grant access to this table. User 1, though, we only want to be able to access these columns down here. However, we have a second user who also needs access to this database. However, we want to give them a completely different view based on their role because they only need access to these columns up here. So what lake formation allows us to do is grant permissions to these individual users to only be able to view the data that they have access to, or they should have access to. So there are 2 different types of data access control that I'm going to talk about real quick, and then I'll walk through an example of what this looks like. The first one is going to be data access permissions. So this is enabling your users to be able to actually read and write data to the underlying S3 locations that are in your data lake. The second is a data location permission. So this is enabling your users to be able to create the metadata itself, which consists of the databases and the tables, and those databases and tables are ultimately pointing to S3 locations behind the scenes. So let's walk through an example to help clarify what this means a little bit. So we have our data catalog over here. Our data catalog consists of 2 databases, database A and database B, both of which comprise of multiple tables. Now, database A has no direct registered location assigned to it, but database B does. It has this customer service bucket here. And this pillar right here is a representation of our data lake. So this is our S3 bucket, and then we have multiple different sub buckets beneath it. We have a data lake user who we have granted create table access on both of these databases, database A and database B. We have also granted data location permissions for this data lake user on this products bucket right up here. Now, let's run through some scenarios. Let's say our data lake user is trying to create a table at a particular database at a particular location. Let's determine if they should or should not be able to based on our lake formation permissions. So first, our data lake user is going to try to create a table on database A at the finance and sales location. So again, our data lake user has create table access on database A. However, database A does not have a registered location for finance and sales. We also have not specifically granted data location permissions for our data lake user for these locations. Therefore, our data lake user neither has explicit nor implicit permissions to create this table. All right, scenario number B. We have database A, where our data lake user is trying to create a table at the products location here. So our data lake user has create table permissions on database A. Database A does not have a registered location for S3. However, because we have specifically granted data location permissions for our data lake user on the products bucket, this user now has explicit permissions to create this database successfully, or this table successfully. Third scenario, so now we're moving to database B. So our data lake user has permission to create table at database B. Database B has a registered location of customer service, but we're trying to create a table at HR and plans. So as you'll see here, because this is not a registered location of database B, and because our data lake user does not have data location permissions to that folder, they neither have explicit nor implicit permissions. Now, let's go back to database B, and now let's try to create a table at our customer service and incidents location. So our data lake user has access to create a database on database B. Database B has a registered location for customer service, and the incentives bucket is a subdirectory of this customer service. So even though our data lake user, we did not grant them direct data location permissions to this sub bucket, because we have granted them access to database B, and because database B has permissions on this registered location for customer service, our user now has what we call implicit permissions to successfully create this table in the database. So Ilya went over this earlier, so I'm not going to dive too much into it, but this is going to be the reference architecture for the demo that I'm going to be showing here in a few seconds. We're going to have a marketing user, a fraud analyst user, and a credit risk analyst user, which are AD users. We're going to have them authenticating into an Apache Zeppelin notebook, which is going to redirect them to their corporate single sign-on page, which is going to then take their authorized SAML assertion and send that to the EMR cluster. The EMR cluster is then going to forward that to Lake Formation, and Lake Formation is then going to grant temporary security credentials back to the EMR cluster, which it will then ultimately use to query the data that's sitting in our data lake. So here are our three users that we have here: our marketing user, our fraud analyst user, and our credit risk analyst user. And here's an example of one of the tables that we're going to show. So we have a credit card customers table, which represents our customers for our credit card line of business. Now, we want our marketing team to have access to this table, but we don't want them to be able to access these sensitive fields down here. So what we're going to demonstrate today is how we can set up grant permissions within Lake Formation to give our marketing user only access to the non-sensitive fields. However, because we have our two other users here, our fraud analyst and our credit risk analyst, they also need access to this table. However, they may actually need access to these fields in order to perform their jobs. So we're going to show a quick walkthrough of how we can actually set that up in Lake Formation. All right, so here I am at the Lake Formation console. When you very first go to Lake Formation for the first time, you're going to be taken to this screen. The very first thing you have to do within Lake Formation is assign what we call a Lake Formation data lake administrator. And your data lake administrator is just exactly that. They are the administrator of your data lake. They're going to be responsible for being able to view all of the metadata that's in your catalog, and also be responsible for granting and revoking permissions for your users and for other administrators. So now let's jump into databases. So once we have an administrator, we need a logical way to represent the data that's sitting in our data lake. And we do that at the top level with the database. So in the interest of time for this demonstration, I've already created the database and the tables and populated them with data. So as you can see here, I've created this data lake DB. And this data lake DB is referencing my data lake location, which in this case is going to be my Jeremiah-data lake S3 bucket. So once we've defined our database, we can start adding tables to that. So there's a couple different ways you can add tables to your data catalog. You can create tables directly from the console itself. You can also use blueprints that I mentioned earlier, which are the templates that we have set up that will automatically ingest data from popular data sources like a RDS instance or a MySQL instance sitting somewhere. It will automatically set up a workflow to ingest that data into your data lake and also create those tables for you. Or the mechanism that we used to create these tables was actually the glue crawler. And so Ilya mentioned this a little bit earlier, but the crawler is a way for you to discover data on S3 and automatically infer schema and discover tables that you can then add to your data catalog. So here you'll notice we have 3 tables here. We have our credit card customer table, we have our credit product table, and then we have a table representing our commercial lending customers. So what we want to demonstrate now is how do we grant access to these tables? We've set up our metadata, but how do we grant access to our users? So you'll see down here, there is this data permissions tab. So if we click on data permissions, we can look first at the high level overview, which is going to show your data administrator every single person who has some sort of access on your data lake. So this is, again, that centralized view of all the permissions that are currently being used within your data lake. So let's go ahead and do a filter. Let's look at my data lake database, and let's start by looking at our credit card customer table. So in the interest of time, I've already gone ahead and created 2 of our users, our credit risk analyst user and our fraud analyst user. But now I want to show the process of granting access to our marketing user. You'll see up here you have this button for grant or revoke. We're going to click on grant. And the first thing we're going to see is we need to determine which user we want to grant permission to. So we can select either IAM roles or IAM users, or we can use Active Directory users. So in this case, as Ilya just explained earlier, we've already established trust between our identity provider, which is AD in this case, and AWS. So what we can do then, whenever you establish trust, you are given a resource identifier for your identity provider. So I'm going to go ahead and enter mine in now. And then what we need to do now is we need to reference whether we are going to be adding a user or a group. So the marketing user is an individual AD user, and so I just need to do user, and then I need to enter in the login name of my user within my Active Directory. So in this case, it's simply just marketing. Now, once we specified which user we want to grant access to, we need to select which database we want to give them access to. In this case, I'm going to select my data lake database here. And then we get this drop down for tables. So I want my marketing users to be able to access my credit card customer information, but I don't want them to be able to see those sensitive fields. So whenever we select a table, we're given an additional drop down for columns. And so what this allows us to do is either include columns that our marketing user is able to see or exclude columns that we don't want them to see. So in this situation, we're going to choose exclude columns. And what this is going to do is create another drop down, which gives us a list of all of our columns that are currently in that table. So what I want to do now is I want to exclude the columns that I do not want my marketing user to have access to. So we'll go ahead and select credit card number. We want to select the customer date of birth and the social security number. Next, we need to list the table permissions that we're granting to this user. So in this case, I don't want to give my marketing team the ability to drop or edit tables. I just want to give them read-only access. And so I'm going to choose select in this situation. There's another section down here called grantable permissions. This is if you wanted the ability to grant your marketing user the ability to grant other users permissions. So in this case, we don't want that. We just want our marketing team to be able to read the data, and so we'll select grant. Now you'll see the 2 other AD users that I pre-created, the fraud analyst and the credit risk analyst. Both of these are AD users, and they have select access, but we've given them select access to the entire table. So as you can see here, they have access to the database, the credit card customer table, and then this wild card right here means that they have access to every column on that table. Now, let's go look at our credit loan table. So if we look at our commercial lending line of business table, you can see that I've also already pre-created the AD user for the fraud analyst. However, we don't want our credit risk analyst having any access to this commercial lending table because it is a completely different line of business. Only our fraud analyst has to analyze the data from multiple lines of business for their use case. So our credit risk analyst doesn't need any access to this table whatsoever, so you won't find them here at all. However, we do want to go in and add our marketing user. Again, we just want to grant them access to the fields that they're allowed to touch. So I'm going to do the same thing again. I'll do user, marketing. We'll select our data lake database. I will select our commercial lending customer table. And again, I'm going to exclude columns. So the columns that I want to exclude here are going to be our customer social security number, their date of birth, and then I also want to block the balance because I don't want to show my marketing user the balances of my customers. All right, and then so again, I only want to give read-only access, so I'll select here and hit grant. So now what we've done in Lake Formation is we've created our database, we've created our tables that are representations of the data that's actually sitting on our data lake, we've granted permission to our AD users. So now what does this look like in practice? So I have a EMR cluster that is currently set up that I've established a link to my identity provider single sign-on page. And so what we're going to go through now is I'm going to try to log into a Zeppelin notebook and start executing some queries against these tables that we created. All right, so the first thing you'll notice here is I'm going to enter in the location of my Zeppelin notebook. Now what you'll notice is once I hit enter, you're going to see this redirect process happen. So as you notice, it's now redirected me to my identity provider single sign-on page. So here is where I'm going to log in with my AD credentials in order to log into this notebook. So I'm going to log in as the marketing team and enter in my super secret password and sign in. And so as long as I am an active user within my Active Directory, it will successfully be able to sign me in. It is now taking this SAML assertion, sending it back to our EMR cluster, which our EMR cluster is then going to communicate with Lake Formation. Now let's open up my marketing notebook that I have here. And so first thing I want to demonstrate is that we gave access to 2 different tables, but we had 3 tables total. So first let's check and see can our marketing user view all the tables, or can they just view the tables they have access to? So we'll go ahead and let Spark go ahead and kick this off here. We're running some Spark SQL code. And what you'll notice is that Lake Formation will only show the tables that we have granted access on. And so what this allows you to do is this is a filtering process that we do, where even if a user is trying to view something that they shouldn't be viewing, the filter process will not even show them that it exists. And so in this case, our marketing user won't even be able to see that our credit product table even exists. So while this is running, let's move on to the next section down here. So we've granted permission to the credit card customer table and to the commercial lending table under the, so here we go here. So you can see we're only able to see the 2 tables that I granted access to. So now we've granted access to those tables, but remember we restricted which columns this user was going to be able to access. So let's run a select star. Let's look at every single column that I have access to as my marketing user. Now, what's happening here is, again, that filtering process. So Lake Formation is using those temporary credentials to access the data that's in S3. It is then filtering the columns that we do not have access to. So as you notice here, I get a list of all the columns that I have access to, but I have no idea as the marketing user that there are additional columns that have sensitive data that I shouldn't be accessing. Now, let's say, for example, I'm feeling a little mischievous. I'm the marketing team. I know that there's a customer social security number column, and I want to see if I have access. Let's just see if I can access this sensitive data here. So if I run this command here, I'm running a select against the customer social security number from a table that I do have access to. And what you'll see is you'll see an exception. It says cannot find this column whatsoever. And the reason is because that filtering process. So we've only granted access to these columns right here. And so as you can see, whenever the Spark SQL command is running this query against this data, it's only returning these columns which I have access to. And so for that reason, we are not able to access the sensitive fields that I should not be accessing. Now let's access the notebook for our credit risk analyst. So again, we try to access our notebook. It redirects us to our corporate login page. We're going to log in as our credit risk analyst. And we're going to log in with their AD credentials. Again, this user does exist in our Active Directory. Therefore, we're able to authenticate them. So you'll see up here, I'm logged in as my credit risk analyst, and I'm going to go to my credit risk analyst's notebook. All right. So again, we only gave our credit risk analyst permission on 2 tables. We gave them access to our credit card customer table, and then we gave them access to our credit product table. So again, if we run this show tables command, it should only show us the tables that we have access to. Now, we gave full select permissions to our credit card customer table. So if I run a select star now, we should be able to see all of the columns that are in this table to allow me to do my job successfully as a credit risk analyst. All right, so as you can see here, I can only see the 2 tables that I have access to. Now, we ran a select star against our credit card customer table, and now because I have full permissions to this table, I'm now able to see those additional fields that our marketing user could not. Credit card number. Now, again, let's say our credit risk analyst maybe isn't being mischievous, but maybe they just make a mistake and they try to access the commercial lending customer table thinking that they should have access to it for their job. So if we just run a very simple select star command from our commercial lending customer table, we should get Lake Formation throwing us an error. And so as you can see here, you're getting an exception saying unable to fetch table commercial lending customer because I have insufficient Lake Formation permissions. So therefore, I'm not able to access any of the tables that I do not have direct permissions for. Now, the last little bit that we want to showcase here is the audit piece that we were talking about. So if we click on dashboard here, and you scroll down, you see this list of recent access activity. So all the activity that's happening within our data lake is going to be populating here. And so as you can see, I'm logged in as my Lake Formation administrator. So every time I click on this data permissions, it's making an API call to list permissions. So you can see I'm doing a whole bunch of that. Now, you also see some of these principles being called from, these look like EC2 identifiers. And so what this is this is actually my EMR cluster. So this is the master node of my EMR cluster. And so what it's doing is trying to get temporary credentials from Lake Formation because it needs those temporary credentials in order to actually access the data that's in S3. And so if we wanted to, we could actually explore these data access events. So if we select the event, we can look at view events, and it's going to show us the events from this request that was being made here. So we can see that the source IP address was trying to call. It was using this role, this IAM role. The SAML assertion is obviously hidden due to security reasons, but it was trying to access our SAML provider here. So the one that we defined in IAM. And you can see what this principle actually was this was our instance profile for our EMR cluster from our master node. What this dashboard allows you to see is all of the access activity that was related to your data lake. Now, I'm going to go over a few more slides and then kick it back to Ilya, and then we can wrap up with questions. All right, so why integrate EMR with Lake Formation? So hopefully today you saw some of the benefits of that. Being able to take advantage of this fine-grained column-level access control to these databases and these tables allows us to have these multi-tenant EMR clusters have secure access to our data. So using the Glue data catalog, we're able to unify that metadata into one location and then set permissions, fine-grained permissions on that data. And then finally, another benefit was using that federated single sign-on from your enterprise identity system. So like Ilya mentioned, instead of having to manage users in your Active Directory and an additional set of users in AWS, tying those two together allows you to use something like ADFS, which we showed today. You can also have support for other identity providers that support SAML markup language, so such as Auth0 and Authka, and a few others as well. Now, currently, Amazon EMR's integration with Lake Formation is limited to using the Glue data catalog. You can use identity providers that have support for SAML, and then the applications on EMR that are currently being supported are going to be Spark SQL, Amazon EMR notebooks, which we didn't display today, but also Zeppelin notebooks that are hosted on your EMR cluster, like I went through in the demo today. So with that, I'm going to kick it back over to Ilya, and he will wrap up.
Thank you, Jeremiah. That was great. So I just want to close off with a couple of additional slides, and then we're going to take some questions. First, let's just summarize what we've learned today. We discussed key financial services use cases for data lakes. We reviewed key considerations and architecture patterns for data lakes in AWS. And we had a great demo of Lake Formation with EMR and Active Directory integration, which gives you that fine-grained access control. We have some additional resources that we would recommend. If you want to learn more about use cases around financial services, please check out AWS Financial Services resources section. We also have some great documentation on Lake Formation if you want to get started. And we have a really great workshop that you can actually do within your organization. And of course, please feel free to reach out to your account teams, and we'd be happy to provide additional information. With that, we want to take some questions in the remaining time that we have.